In Chapter 10, we begin our study of conic sections. This video introduces the parabola as a conic section. Precalculus Online starts now. In section 10.2, we look at parabolas. So we all kind of know what the parabola is, but this section looks at the parabola in sort of a different way. We'll be able to orient the parabola going up and down, left and right. And so let's sort of take a little look at it here. Let me start with the XY grid. And one standard parabola is to place the vertex at the origin, and then the parabola comes out like this. And then there are two other aspects that are sort of the main aspects of the parabola. And this is going to be sort of a repeating theme throughout this chapter, where the relationships between the points are what are important about these graphs and things. The first point that I want to look at lies about right here, and this is called the focus. And let's go ahead and say that the distance between the vertex and the focus is A. And then the other aspect that we want to look at is this line here. Draw it as a dashed line usually, and give it a D, and that is called the directrix. And the relationship between all these is that if A is the distance between the focus and the vertex, then A is also the distance between the vertex and the directrix. Now, if I have these and it's oriented facing up, then the equation is x squared is equal to 4ay, where the a in this equation is that distance between the focus and the vertex. So some people call a the focal distance. And the focus is the point, in this case, 0a, and the directrix is a horizontal line, y equals -a. Now this is just one aspect of the parabola when it's oriented like this. What we want to look at now is what is the technical definition of a parabola. So a parabola is the set of points in the plane that are equidistant from a fixed point and a fixed line. Set of points in the plane that are equidistant from a fixed point and a fixed line. Well, that fixed point is the focus, and the fixed line is the directrix. So what you're seeing is that some point on the parabola, and this may not be drawn very well, but the distance from that point to the focus is the same distance to the directrix. So it's not quite drawn to scale. But these two distances should be the same. Let's say distance, distance. So now let's go ahead and take a look at the derivation of the basic equation using our definition of a parabola. So first let's let the fixed point be the focus, f at 0, a, and the fixed line be the directrix. Y equals negative a. Let me sketch the parabola. And here's the focus. And here's the directrix. And the focus is 0, a, and the directrix is y equals negative a. And then we're going to take this point here, P, which is going to have coordinates x, y. Now the P is going to represent any point on the parabola. So let's just write that down. Let P, x, y represent any point on the parabola. And since it is any point on the parabola, we know that the distance from P to F is the same as the distance from P to D, the directrix. So let's write that down. So the distance from P to F is equal to the distance from P to Q, let's say, and then we'll call this point here on the directrix Q. And that's from the definition of the parabola. Those two distances have to be the same. Again, the picture may not be quite right, but it does work. Now, let's just go ahead and see what we get out of this. So one thing to remember, that if the distances are equal, then the square of the distances must be equal. The distance formula uses a square root. We don't have to use the square root, because if they are equal as far as the distance is concerned, then the squared distance must be equal as well. So we'll skip the square root part here. And then let's find the distance from P to F. The difference in the x's, so x minus 0 squared, plus the difference in the y's, y minus a, and then that's going to be equal to the difference in the x's from P to Q. Well, those have the same x value because of the way we drew the picture. So it's x minus x squared, plus the difference in the y's. So it'd be y minus the y coordinate at Q, which is negative a, squared. Well, the first thing, x minus x squared is 0, so I can eliminate that. On the left side, x minus 0 squared is just x squared. I can expand y minus a squared, and we know how to do this using the binomial theorem. We get y squared minus 2ay plus a squared. And then we'll expand this. Now I'm just going to go ahead and rewrite it right above it here. This is actually y plus a squared. So this works out almost the same, except this middle term is positive 2ay and then plus a squared. And then cancel what you can. We have y squareds on both sides. We have a squareds on both sides. They cancel. We have 2ay on the right and negative 2ay on the left. So if I just move the negative 2ay to the right, I get x squared is equal to 4ay. And that's the generic equation of the parabola. Example 1. Find the equation of the parabola with vertex 0, 0 and focus at 0, 2, then graph the parabola. So I actually find it helpful to sort of graph the parabola to start with. Let's we're going to have a vertex right here at 0, 0, a focus at 0, 2. That means we have a directrix at y equals negative 2, because the focus and vertex are the same distance from the vertex and the directrix. And so what is the distance between the vertex and the focus? That is called A, and it's 2 units. So we're going to have x squared is equal to 4ay, and so x squared is equal to 4 times 2y, and x squared is equal to 8y. And that's the equation of the parabola. And let's do a little sketch here. So it's probably very wide. And don't get confused about what you remember from algebra about how wide and narrow a parabola is. The number is in the wrong spot if you're comparing it to college algebra. So in college algebra, we would have written this as y equals 1/8 x squared, which would be very wide. The closer this gets to 0, the wider it is. So make sure you see the difference between those. All right, let's take a look at some variations on the parabola. So we already have this one. X squared is equal to 4ay, which means that it opens up, centered at the origin. Then we can have y squared is equal to 4ax. So we've switched the roles of the x and the y. Since the y is squared, that means it's going to open up left or right. And in this case, it opens up to the right. The coefficient in front of here is positive. And then x squared is equal to negative 4ay. It's going to open down. And then y squared is equal to negative 4ax, opens to the left. Example 2. Analyze the equation and graph. Y squared equals 24x. So this is in the form of y squared is equal to 4ax. It means it's going to open up to the right. And we need to figure out what the a is. Well, the coefficient of the x is 4a, but it's also 24. So the a must be 6. So the focus is going to be at 6, 0. The vertex will be at the origin. And the directrix will be a vertical line, x equal negative 6. And the parabola opens up to the right. Example 3. Analyze the equation and graph. X squared is equal to negative 4y. So this one is in the form of x squared is equal to negative 4ay. So negative 4a is equal to negative 4, which means a is equal to 1. Because it's in the form of x squared is equal to negative 4ay, it means it goes down. And then let's draw it and then create the analysis. So it's still centered at the origin, that's the vertex. The focus is going to be 1 unit away from the vertex, but because the parabola is going to go down, the focus is down as well. The directrix is going to be 1 unit away from the vertex, but that's going to be above. The directrix is always outside of the parabola. It's going to look like this. Let's write that down. Vertex is at 0, 0. Focus is at 0, -1. Directrix is the horizontal line y equals +1. Next, let's look at how we shift the parabolas around. So the basic equation now becomes the following. X minus h squared is equal to either a plus or minus 4a times y minus k, where the vertex has now been shifted to the point h comma k. Notice how the h is with the x. It's inside before you square it, and therefore you have to use a minus. It's x minus h, not x plus h. And the same thing with the y. The y has to be y minus k, so it's subtracted, and it's together before you multiply by 4a, so that has to be subtraction on the inside as well. Similarly, for the parabolas that go left and right, we can have y minus k squared is equal to plus or minus 4a times x minus h. Again, the vertex then becomes h comma k. And one other thing to note, since the vertex is being shifted, then the other aspects of the parabola will be shifted as well, the directrix and the focus. Example 4. Analyze the equation and graph. Y plus 4 squared is equal to negative 8x. So in the basic form here, we're going to have a vertex that has not been shifted along the x axis, but it has been shifted along the y-axis to -4. We see that it is in the form of a y squared is equal to a -4ax. So since it's a negative, that means it's going to go to the left because the y was squared. But it's been shifted. And now let's figure out what a is. So -4a is equal to -8. So the a is equal to 2. But we just have to remember that it's a shift going to the left when we do all these things. So let's go ahead and create a little graph here. So the vertex starts down 4 at -4. The a is 2, so I'm going to mark off 2 to the left, and that's going to be where the focus goes. And let's mark all this. So the vertex is 0, -4. The focus is now -2, -4. The directrix is going to be 2 to the right. So the directrix is the vertical line, x is equal to +2. And the parabola is going to open up to the left. Now there's one other aspect I want to introduce to you at this time. This is called the latus rectum. The latus rectum is the segment that is on the parabola but passes through the focus on the inside here. So this is the latus rectum. And what you'll be asked to do is find the endpoints of the latus rectum. So this point here and this point down here. So let's start with the equation. It would be y plus 4 squared is equal to -8x. And what we know is that the x-coordinate for the focus and the lattice rectum endpoints are all equal to -2. So y plus 4 squared is equal to -8 times -2. That means y plus 4 squared is equal to 16. Take the square root, we get y plus 4 is equal to plus or minus 4. And then we get y is equal to -4 plus or minus 4, which is equal to 0 and -8. So that means the endpoints of the lattice rectum are -2, 0, which is this point here, and -2, -8 down here. Example 5. Find the equation of the parabola whose directrix is y equals 7 and whose focus is 2, 1 in graph. So let's go ahead and make a little graph. So the directrix is y equals 7. That's a horizontal line. 3, 4, 5, 6, 7. It's a horizontal line at y equals 7. The focus is at 2, 1. Now we know a couple of things. We know that the directrix can tell me the orientation. Since the directrix is horizontal, then the parabola either goes up or down. We also know that the parabola has to envelop the focus, so it must go down. But the other critical point that we know is that the vertex is exactly halfway between the directrix and the focus. So halfway between 1 and 7 is 4. And has to be in line with the focus and the directrix and the straight line from that point to that line. So the vertex must be at 2, 4. So that means I can create the parabola. Now this is just a little sketch here. I don't know exactly what it looks like. But since it's going down, that means I have x's in the squared position. So it's going to be x minus 2 squared is equal to negative, because it's going down, 4a times y minus 4. Now the only thing left for me to find now is what was the a. Well, the a is the distance between the directrix and the vertex, and that was 3, or the vertex and the focus, which is also 3. So a is equal to 3, and that gives me x minus 2 squared is equal to -4 times 3 times y minus 4, and that's x minus 2 squared is equal to -12 times y minus 4. Example 6. A satellite dish is shaped like a paraboloid of revolution. Paraboloid of revolution is just when you take a parabola and you spin it around its axis of symmetry. It spins in free space and it creates a little dish, just like it's a satellite dish, just like you exactly think what a satellite dish should look like. The dish is 12 feet across from its opening and 5 feet deep at the center. Where should the receiver be placed? All right, so what is the key to this? What does the receiver have to do with anything with the parabola? Well, it turns out that, let me draw a little picture here. Let me just draw it sort of a cross section. Suppose you have a parabola and you have rays coming into the parabola. Then the rays that come in bounce on the parabola and all get reflected to some point here in the center, like so. These rays are perpendicular here, which is sort of the point there. And they always get bounced to there. Well, the question is, what point is that? Well, it turns out that's the focus. And so the receiver on the dish has to be placed at the focus so that all the signals from the satellite come in, hit the dish, and then bounce to the focus. That's why your satellite dishes are shaped like a paraboloid if you look at the cross sections of them. So let's go ahead and draw a new picture for this particular scenario. The dish is 12 feet across at the opening and 5 feet deep at the center. So I'm going to draw it like this. Goes across like this. So this point here is going to be where y is equal to 5, because it's 5 feet deep at the center. And then it's 12 feet across at the opening. Well, I'm going to split that up into 6 and -6. So it's 6 on each side. So we know that this point here can be represented by 6, 5. Now notice some of the conveniences that we've used in this. We've put the vertex at the origin, no problem. And you can do that to make your calculations simpler. Let's go ahead and write up the equation. So the equation would be x squared is equal to 4ay. We need to figure out what the a is to complete the equation. We don't have any information about the focus, that's actually what we're trying to find, or we don't have anything about the directrix. What we do have is that the point 6, 5 does lie on the parabola. That's an x and y ordered pair that I can place into the equation, and I can use it to solve for a. So 6 squared is 36, is equal to 20a. So a is equal to 36 over 20. I can reduce that by 4. That gives me 9 over 5, which is 1.8, because this is an application, that's fine. And what that means is that the focus needs to be 1.8 feet from the vertex. So focus is 1.8 feet from the vertex. And that describes where the receiver should be. So maybe we should just say receiver is 1.8 feet from the vertex.